All right, so we have a question here. We have to express this as a partial fraction, right? So the first thing that you need to determine is whether it's a proper fraction or an improper fraction. So whenever, if the denominator has a higher degree than the numerator, for example, let's say we have 1x over x squared, this is a proper fraction. But if the numerator has a higher degree than the denominator, for example, 3x squared over x, this is an improper fraction. All right. So we can see we've got three linear denominators here. When you multiply out these linear denominators, you're going to get x to the power 3. So what this tells us is our denominator, it has a higher power than our numerator. Right? So for this question, there is no need to expand these brackets and then find the expression, right? Because it's already been factorized for you. So the next thing that we need to do is now we need to break down this fraction, all right? So the first thing we're going to do, we say equals, we're going to write down each of our denominators. So we have x plus 1 plus here x plus 2 plus x plus 3. All right. Now remember, our numerator has to have a lower power than our denominators. So our numerators are going to be constants. A constant is just a number without a variable attached to it. So you're going to write here A, B, and C. Right. If, for example, if it was x squared here, then our numerator, since it has to be, its variable has to have a lower power. Our numerator will be ax plus b. All right. So I just want you to take note of that. But in this case, since we have a linear denominator, so we are okay. So here what we're trying to do is we want to find the value of a, b, and c. So to do that, let's get rid of our denominators. All right. So we can multiply this whole expression by the denominator, all right, which is x plus 1 x plus 2 x plus 3. All right. So if we multiply this expression with 3x plus 5, we cross out the whole denominator, right? And we remain with 3x plus 5. When we multiply out this whole expression with a over x plus 1, since we have an x plus 1, so we'll need to get rid of this one here, this x plus 1. So we're going to remain with x plus 2 and x plus 3. So we'll have equals a, open brackets, x plus 2, close brackets, open brackets again, x plus 3. Plus, if we multiply this whole expression again, x plus 1, x plus 2, x plus 3, with b over x plus 2, our x plus 2 is going to go. We're going to erase this x plus 2. So the remaining factors will be x plus 1 and x plus 3. So we're going to have b, open brackets, x plus 1, x plus 3. Right, then if we multiply out this whole expression, x plus 1, x plus 2, x plus 3, we multiply it with c over x plus 3, we're going to get rid of the x plus 3, and the remaining factors will be x plus 1 and x plus 2. So we're going to say plus c, open brackets, x plus 1, x plus 2. All right, so now I have to find the values of a, b, and c. So we can use the elimination method. All right, we can pick certain values of x which are going to which can get rid of any of these expressions here. So for example, if we say if let x equals -2, all right, so this expression becomes 3, open brackets, -2 plus 5 equals, so we have a, open brackets, so we have a -2 here, -2 plus 2. All right, so we know with -2, we're going to get rid of a and c. All right, so even here we're going to have again -2 plus 3 plus b, open brackets, -2 plus 1 close brackets, -2 plus 3 close brackets, plus c equals, open brackets, -2 plus 1 and our final one we have -2 plus 2. So as I said here, the reason why we're using -2, we want to find the value of, let's see here, we want to find the value of b, okay? Because if we substitute x for -2, as you can see here, -2 plus 2, that is 0. 0 times a times -2 plus 3, that's 1, times 1 gives us 0. All right, so here we're going to have 0. Even here with c, -2 plus -2 plus 2, that is 0. -2 plus 1, -1. 0 times -1 times c, that is 0, right? But for b here, -2 plus 1, that is -1. -2 plus 3, that is 1. 1 times -1 is -1 times b is -b. All right, so we'll be able to find the value of b. 3 times -2, that is -6, plus 5, that gives us -1. So we have -1 equals -b. What we can do is just multiply both values by -1. Okay, -1 times -1, that gives us 1. And -1 times -b, that gives us +b. So b equals 1. All right. Next, let's try to find the value of a. So as we can see here, if we make x equal to -1 or -3, we know that our b will be cancelled out and our c will be cancelled out. All right, so the next thing let's do, we're going to say let x equal -1. So you should always look in the brackets and see if you can be able to attain a 0. Once you have a 0, it is going to make the whole expression disappear. So when x is -1, so now I'll do it a bit faster. All right, so when x is -1, we know if we replace here x with -1, -1 plus 1, that is 0. So we know our b constant will go. We've also replaced -1 here, -1 plus 1, that is 0. 0 times this and c, we know that this expression will go. All right, so when x equals -1, let's go back. We have our expression here, 3x plus 5. So we're going to have 3, open brackets, -1 in here. 3 times -1 plus 5 equals. So when x equals -1, if we substitute -1 here, we say -1 plus 2, that is 1. -1 plus 3, that is 2. 2 times 1 times a, that gives us 2a. So here we're going to have 2a. 3 times -1, that is -3. -3 plus 5, that is 2. So we're going to have 2 equals 2a. So to get the value of a, we just divide both sides by 2. Okay, and then a equals 1. So found the value of a and the value of b. So now we have to find the value of c. So again, we'll come to our expression here again. Okay, 3x plus 5 equals a, x plus 2, this expression here. Then we're going to ask ourselves, which number must we replace x with so that we can get rid of our other expressions and remain with c, so that we can find the value of c. So if we make x equal to -3, we're going to say let x equal to -3. Right, so if we come back to our expression here, all right, if we replace x with -3, -3 plus 3, that is 0. 0 will cancel out this expression here. Even here, replace our x with 3, -3 plus 3, that is 0. 0 cancel out this expression. All right, and that will enable us to find our value of c. So replace x with -3. -3 plus 1, that is -2. Even here, we're going to say -3 plus 2, that is -1. So we're going to have 2, -2 times, so here it was -3 plus 1, that's -2, -3 plus 2, that's -1. So -2 times 1, that's +2. 2 times c, that's 2c. All right. So we've got our expression here, 3x plus 5. We're going to say 3, open brackets, -3 plus 5 equals 2c. Negative 3 times negative 3, that's negative 9. Negative 9 plus 5, that's negative 4. So say negative 4 equals 2c. To get our value of c, we're going to say c equals negative 4 divided by 2. That gives us negative 2. So we are done. We found our value for b, value for a, and the value for c. So all we need to do is go back to our original expression, which we started with. All right, this one here. So we're going to replace a with 1, b with 1, and c with negative 2. So let me rewrite the expression. So the expression is going to be 3x plus 5 over x plus 1, x plus 2, x plus 3 equals, all right, so equals, so in this case our a was 1, so we say 1 over x plus 1 plus our b is also 1, so we're going to say 1 over x plus 2, and our c was negative 2, so we'll say plus negative 2 over x plus 3. So one way to check if your answer is correct is you can add these fractions here to see if they give you this answer. All right. So our answer is 1 over x plus 1 plus 1 over x plus 2. This positive and negative make negative minus 2 over x plus 3. So that's how you do with expressing fractions as partial fractions.